Welcome to the Math Show with Mr. DeClerico. If I had a dime for every time I heard this sentence, I would be a very wealthy man. But it's not math that doesn't make sense. It's us who don't make sense. Myself included, of course. That's why we need to train in proper ways of doing math. But just like weightlifting, bad form leads to mixed results at best. Today we're going to talk about 3 ways that we can mess up our algebra, just so we're extra careful about how we develop our mathematical technique. Error number 1. Dividing through by a variable. Let's say we were given this equation to solve. Suppose I were to divide through by the variable x. Well, after cancellation, that would give me x equals 2, which is true, but incomplete. But why? Well, think about it. If I'm dividing through by x, I'm assuming that x does not equal 0, because you can't divide by 0. But unfortunately, 0 is one of the solutions to this equation. Bummer. Fortunately, this is an easy fix. We should set up zero product property by subtracting a 2x on both sides. That would give us x squared minus 2x equals 0. Now we see a common factor of x on the left-hand side. Factor that out, and then we can solve using zero product property, x equals 0 or x equals 2. Fixed it. Here comes error number 2. Forgetting plus or minus when solving by applying even roots. Let's say we were given this equation to solve. At first glance, you might think, oh, x equals 4, which is true, but again, it's incomplete. But why? Look at that original equation. 4 squared does equal 16, but negative 4 squared also equals 16. We should include a plus or minus next to that 4 to make sure we account for the fact that 4 and negative 4, if you square it, give you 16. Fixed it. Now let's consider this equation. In this equation, just like our first, we have an even power to undo, so we would use an even root. Applying the 4th root to both sides, we would need to remember a plus or minus next to the 2 on the right-hand side. Because if quantity x plus 1 to the 4th equals 16, then x plus 1 has to be either positive or negative 2. If we were to then subtract 1 on both sides, we would get negative 1 plus or minus 2 equals x. And here comes Mr. Monk to remind us, please, never leave it in this form. That's more like it. So does this apply to imaginary solutions? Oh, you bet it does. Consider this equation. If I were to square root both sides, I would not only need to use I, but the plus or minus. Oh, wait, gotta simplify. But does it apply to odd roots? Well, no. An odd root of a positive number is positive, and an odd root of a negative is negative. Simple enough. What's not so simple for many students is how to avoid our third and final error: canceling with rational expressions. But before we begin,
a moment of silence for the order of operations errors caused by sloppy attempts to simplify rational expressions.
Attention math doers everywhere. You can only cancel common factors of the numerator and denominator. Do this or face the wrath of the monks. I know it's tempting to look at something like this and say, oh, I can just cancel those x's and get that. Well, the only thing you should be canceling is that equal sign because it's a trap. The question you should be asking is, do the numerator and denominator have any common factors? That is, if I want to cancel x, can I conveniently factor an x out of the numerator without making a mess? The answer is no. So you should make like the Beatles and, I repeat, you can only cancel common factors of the numerator and denominator. So when can we cancel with rational expressions? Let me give you an example. Here, I can factor out an x in the numerator, Then I see that I can cancel the x's because an x is a factor of both the numerator and the denominator. That gives me this answer. And why can't x be 0? Because it can't be 0 in the original expression. Here's another instance in which I can cancel. If I factor the numerator, I'll see that I have an x minus 1 in common. That common factor of x minus 1 can be canceled, which leaves me with x minus 3, given that x is not equal to 1 because, again, I can't substitute 1 in the original expression. So let's go through our 3 errors one more time. Number 1. Don't solve an equation by dividing through by a variable. Use the zero product property instead. Number 2. Remember plus or minus when solving an equation by applying an even root. And number 3, you can only cancel common factors of the numerator and denominator, so factor first before canceling. Mastering and retaining algebra is no simple task. What's another common algebra error? Drop a comment and let me know. And remember, only you can prevent silly mistakes. And as always, thanks for watching the Math Show with Mr. DeClerico. Be sure to click subscribe, hit the like button, and all that good stuff.